Hi, Marco. It's great to have a chat with you today.
Hi, Sebastian. Thanks a lot for inviting me. It's a great pleasure for me to be here.
So there's a lot of talk these days about progress in NLP, especially with GPT-3 coming out, and even before that with transformer-based models, variants of the transformer BERT, the entire Muppet Show family and stuff. There's a lot happening, right? And so,
yeah.
In practice, what do you see come out of these bits and pieces of progress? Is that all? I mean, does that all go somewhere? Is that practical, or do you think there's still a lot of application work needed?
Well, I think all these models that you mentioned has been recently published. So this means that we are at the beginning, in my opinion, of the exploration of this new technology, of this giant language model producing generating text. So, yeah, in terms of performance, they are producing great advancement in technology, but my personal feeling is that it's too early for having them directly in production. This is my intuition at the moment.
Do you think we're far away from a new paradigm change in NLP where we'll move away from neural networks?
Wow, that's an interesting question. Considering that we start recently to use them with amazing results, you are already thinking what will be the next. Well, let me say that probably this will happen. I don't think it's going to happen soon. Also because we are still in the phase on research where we are still, every time that you change something, you still gain a lot in terms of performance. So we are still in a steep slope of the improvement. No, you don't reach the plateau. So I think that it will happen, as happened for neural network now compared to the past. But it's not going to happen soon, in my opinion.
Any guess at when? Are we speaking 50 years or 10 years?
Well, between 5 to 10.
Okay, it's a pretty precise time frame.
Well, 5 years time frame.
See you in 5.
Of course.
For people who are getting started with NLP these days, so I'm thinking maybe more specifically about people who come to School of AI at PySchool, or students who are learning NLP these days and are discovering the whole range of methods that are current these days and who are not necessarily even familiar with what we used to do 10 or 15 years ago. So people who don't know anything about rule-based systems, certainly, and in terms of statistical systems, only know deep learning era. What do you think they should be learning, or what do you think they should be getting acquainted with to be future-proof?
So what I'm saying is counterproductive for me, but what I'm going to say is that, in my opinion, you need to have a strong background in AI, in deep learning, neural networks. Then you can become a specialist in a particular field. But if you think now at machine translation, well, what is the difference between machine translation, summarization, end-to-end speech translation? Probably the data that you are using, because behind that there is a sequence-to-sequence model. Of course, if you want to become a specialist in the field, you need to start reading and studying what happened in the past, in terms of what helped in the past before the AI era. But in general, that's what I say to my PhD students when they start to work with us. If you want to have a future, you need to be an expert in deep learning. Then we can focus on machine translation, speech translation, and we can find interesting problem there. Mm-hmm. But if you don't have the background in AI, it's quite difficult nowadays to have, let me say, a future.
So you've kind of specialized in machine translation in like since quite a few years now, and more recently you've narrowed that down to spoken language translation, and even more specifically, the challenge is speech-to-text translation. So you've moved to incorporate not just text, but also spoken language, speech. So that's probably meant a change of methods. There's one thing there in that seems to be a common thread, which is how do you put your hands on data that is useful for the task? It seems that for machine translation, there's a kind of human activity that provides you with a pool of data, which is namely, text translation, document translation. It's an ongoing business. It's a translated business, so that we see that there's plenty of activity there. For speech-to-text translation instead, well, there also is a sort of segment in like subtitling and captioning, maybe also even dubbing. But it doesn't seem that data is as plentiful as for text-to-text translation. What do you make of that in practice?
Yeah, so you are spoiling my presentation. So
very good.
Yeah, so that's one of the main challenges in when we think about speech-to-text translation. For the same reason that you're mentioning, if you think to the parent task, automatic speech recognition and machine translation, for them it's quite common, or as I say, obvious to have data, because there is localization industry, there is the need of to transcribe text, which is quite obvious. Speech translation required to have audio and text in the target language, which is not, of course, obvious. And this is the challenge, because my group also released one of the larger corporates that are available for speech translation using the TED data. There are also other companies focusing on releasing more data. But the challenge is allow the end-to-end speech translation system to leverage the ASI and the empty data. This is the real challenge for technology developers like us. Mm-hmm. Because if we expect that you have the same amount of data that you have now in machine translation, for speech translation, probably you need to wait for a while. So the direction is allow the end-to-end speech translation system to leverage, to use the ASI and the empty data. This is one of the most important research direction in the field.
NLP is sort of presented as one of the hardest tasks in AI. So for instance, it comes up, or language comes up as one of the human faculties that is hardest to emulate. And in the Turing test, it's made, the test revolves around the ability to produce language in the form of dialogue. We see that in modern benchmarks, there's a lot revolving around common sense tasks and testing new algorithms, say GPT-3 or GPT-2, against the glue and the super glue benchmarks, and all of these contain a ton of different variations around common sense and then understanding tasks and things like that. So it looks like there's a propension to assimilate the task of mastering language to solving AI, as in it's made one of the hardest tasks maybe to solve. Do you agree with that view? Or do you think there's still a wide gap between solving NLP, so to speak, being able to produce and understand language, and then what is intelligence?
Yeah, let me say that when in several NLP tasks, there's been always the comments is, okay, you are able to do this, but you are not able to understand the language. I think about name entity recognition, for which the system achieved 90%, 95, 98% of accuracy. This has been for a while the mantra. No, you have good in this, but you don't understand the language. So probably this idea, I don't know if it is related to the fact that for age we thought that neural network as a kind of brain that need to be able to understand everything. We are pushing toward this idea that this system should understand, go beyond the single task and understand the language. Let me say that I'm partially agree in the sense that there are a lot of NLP tasks where the performance, even for tasks that are not required to understand the language, the performance does not reach 99%, 95%. So they are not solved at all. So on one side, yes, I agree that it's important to raise the bar and go in the direction where we can say we want to better understand. We want a machine that understands the language, can create a joke, can understand things. But on the other side, we cannot miss the real one of the important targets: make our tool able to really solve the problem in different languages, in different conditions, because sometimes we test our things in one condition, in one very lab and closed scenario, and then, okay, that's all. We pass the Turing test, let's move on. But it's not, let me say, it's not valid everywhere in all the conditions. So I partially agree with your statement.
Mm-hmm. With regards to business applications, can you see any barriers or any obstacles that are currently still in place at the, say, scientific level and that need to be removed to release some big business potential? Do you think that there's some examples here of things we should be doing or we should be solving?
So yeah, that's a very interesting question. I ask myself several times if we are really considering the potential of the technology we are developing. Sometimes I have the feeling that we are so focused on the problems that we miss the global picture. The fact that sometimes you don't realize that what you have is already good for opening a new business or for solving a new problem. For instance, I'm thinking about the classic end-to-end speech translation. Now that I think that we are mastering in this period, we are trying to focus to customize for subtitling to make it better and better and better. But who knows? Probably whatever we have is already enough for using for information retrieval. So you can transcribe a lot of movies with what we have, and then use information retrieval techniques for looking particular information inside movies and presenting this to the user. Really, I'm thinking loud, so I'm trying to find some possible application. But this can be sometimes one of the questions I pose to myself and also to the person working with me. Are we good in use the potential of what we have in our hands in all possible application, or we are so focused to our problem that we miss opportunities? I don't have an answer. My feeling is the possible answer is yes, but okay. Don't ask me what we can do.
Mm-hmm. Okay, Marco, it was great to do this small interview with you. Thank you for being with us and for being a returning guest at our events and in PyCampus in general. I hope to see you soon. Bye-bye.
Thank you, Sébastien, for inviting me. As usual, it's a great pleasure to talk with you, and I hope that you can meet in person soon. Thanks a lot, and bye-bye.
Thank you. Bye.